Hello everyone. So in this class we will learn law of reflection using Huygens principle. Okay, law of reflection using Huygens principle. So first I am drawing the diagram. You can also draw. Right. So see, these rays are incident rays. You can see, and then this one is your incident wavefront, and this one is reflected wavefront. This is normal. So here it is I and R. I is angle of incidence with respect to normal. R is angle of reflection with respect to normal. Similarly, as this is incident wavefront, whatever this angle is making, that is I, and here it is R. Okay. And this A to E distance, you can see here, this is what velocity into time. Why velocity into time? Because if distance you want, distance is just velocity into time. V into T, this part, AE. Okay. So let's see now. In the diagram, you see AE is equal to BC is equal to V into T. That is distance. Distance is equal to velocity into time. Okay. Next one. Now, which triangles I am considering? See, in triangles, in triangle EAC and triangle BAC. In triangle EAC, EAC where E, A, and C, and triangle BAC. These two triangles. Okay. In these two triangles, what we are getting? See, AE is equal to BC is equal to VT, and angle AEC, that is this angle, this is 90 degree, hai na? Angle AEC is equal to angle ABC. ABC you can see here, ABC, which is equal to 90 degree. And which side is common now? This side, AC, A to C, you can see here. So shall I write here? The side AC is common to both triangles. And therefore, triangle EAC and triangle BAC are congruent and therefore angle I and angle R would be equal. And therefore angle I is equal to angle R. This is the law of reflection. This is the law of reflection. Okay, one more time listen what is in this topic. See, we have to prove law of reflection using Huygens principle. So for that, what we are doing, we are using wavefront theory. है ना? Yesterday we have learned wavefront. So see, consider a plane wavefront incident at an angle I on a reflecting surface mn. Let t be the time taken by the wavefront to travel the distance bc. Okay, can you see these two rays, and this bc is the what distance traveled in time t, because this is a one medium and in which velocity is what phi. Now see, this ray is coming like this and getting reflected. So this is incident angle, this is reflected angle, and this one is incident wavefront. And because of this, you are getting this one as a reflected wavefront. Okay, and this is r, this is angle I. Now just we have to use geometry, that is AE is equal to BC is equal to BT, this one and this one. So therefore you have to show that triangle EAC and triangle BAC are congruent, and therefore angle I is equal to angle R. This is what the law of reflection using Huygens principle. Okay, right? Okay, next. Now, how to prove law of refraction or Snell's law using Huygens principle? So see here. So shall I write as a question only? Okay. So they may ask you like this also. Prove the law of refraction in bracket Snell's law using Huygens principle. Using Huygens principle. What they are asking you? Prove the law of refraction using Huygens principle. So let's see now how it is. So for that, first I am drawing diagram. You also listen carefully and draw if possible with me only. So as this is refraction now, listen carefully. I am taking two medii. So you can see here, this is medium 2 and this black one is medium 1. Now this light ray is incident on this medium like this. Similarly, another ray is like this. And here it is a normal. And now this ray will refract. So therefore it is refracting like this into this medium. Okay, so this is an incident ray like this, and now this is I, this is wavefront, we can say. Which one? This one. Incident wavefront, and this angle is your angle of refraction, R. And now let us suppose this point is point E, and now this is medium 2. Yes, this is what your medium 2 is, and this one is the refracted wavefront, this is incident wavefront. What is this? Incident wavefront. And here it is, reflected wavefront. Refracted, not reflected, refracted wavefront. Yes. Now this point is, let us suppose, point C here at this interface. This point is, let us suppose, point A. This is B, and this angle is 90 degrees. This is A dash incident, and this is your medium 1. Medium 1. So what is the speed? That is V1. What is the speed in this? Speed of light in this is V, and this is P. This point is PP dash, and this is on his medium 2 already I told. This is medium 2, and in this, what is the velocity of light? That is V2. Now this distance is how much? This will be V2 into T, है ना? How much will be this distance? V2 into T, and this distance BC is equal to what? V1 into T, right? Okay, this is I, this is R, already I told, है ना? This angle is R, this angle is I, angle of refraction and angle of incidence. And here, what is the case? Incident wavefront, refracted wavefront. Okay, let's move ahead now. Now see, first point, consider a wavefront incident on the surface separating two media. Consider a wavefront incident on the surface separating two media at an angle I. Yes, you see, consider a wavefront incident on the surface separating two media at an angle I. Now, this is incident wavefront. What will be this angle? This angle is I. Keep it in mind. This angle is I. This wavefront with medium means media. Whatever this refracting media is there, with that, this wavefront is making angle I. Okay. So if we will see this angle, which this refracted wavefront makes with this, that is your R again. Understand? That is what we have to prove. Wait. Clear? And here, which one is greater, Ray? P1 is definitely greater than P2. Why? Because this is denser medium, this is rarer medium. So V1 is greater than P2. That also you can draw in the write in the diagram. Okay. Now it is refracted. It is refracted through an angle R. Through an angle R. Let t be the time taken by the wavefront to travel the distance BC. Let t be the time taken to travel the distance BC. Now, as we know, V2 is greater than V1, and therefore in triangle ABC, sine of I is equal to BC by AC, है ना? BC by AC. So BC is equal to what? But here V1T. So therefore, direct I am writing V1T by AC. Similarly, in triangle, which triangle I am taking now? AEC, नीचे वाला. AEC triangle. What we are getting? Sin R. Sin R is equal to V2T divided by AC. Yes, this is your equation number 1. This is your equation number 2. What we got? V2T by AC, V1T by AC. We got sin I and sin R values. Yes, any doubt? Yes. V1T by AC and V2T by AC. Now, if we will divide these two equations from equation 1 and 2, what we are getting? See, sin I divided by sin R is equal to sin I by sin R is equal to direct I am dividing V1 by V2, T and ACC will get cancelled, so which is equal to V1 by V2, and this is nothing but equal to what? N2 by N1. Yes, and therefore sin I by sin R is equal to N2 by N1. This is what your Snell's law. Already we know this. In ray optics, I told you this, how you are getting N1 and N2 and V1 by V2. Yes, go and refer once, refractive index. There I have proved this, how we are getting this, right? Okay, and this is what your Snell's law. Yes or not? This is what the proof is for this law of refraction. And this is what, by using Huygens principle, we have proved this Snell's law. Okay, so note down and let's stop here.